recording now a bit problem. Okay, now last class we have already go through this one, right? Okay, the what I call that what I call this we call the electrolysis, I guess. Okay. I've been talking about somewhere near this one, electrolysis or the electrolysis. Okay, so let's see the factors that will affect the electrolysis of aqueous solution. Okay, first one, at cathode, if there is more than one reducible species in the solution, so the species with more positive E will be preferentially reduced, means that they will choose the one with more positive. Like for example, sodium and hydrogen. Okay, which normally which one will be chosen? I mean, water and sodium. Which one will be chosen? Which one more positive? Okay, the value is here, he already give you. So which one more positive? This one, this one is small, bigger, more positive means that the value is bigger. All right, this one smaller, this one bigger. Okay, so that's why since the E value is more positive for water, so H2O is preferentially reduced than sodium. Okay, so this is the main reason. All right. At anode, if there's more than one oxidizable species in the solution, the species with more negative value will be preferentially oxidized. So for example, this one, iodine and bromine. Okay, which one is more negative? Means smaller. Iodine, so since the E value for iodide is more negative, so iodide ion is preferentially oxidized compared to bromide. Understand? More negative means small. More negative means smaller. More positive means bigger. Doesn't necessarily say that or more positive. This one should be positive. No, doesn't necessarily. Okay, can you understand? Can I? Okay, jot this down.你又怕 Justin？ 我记得我第一次封1跑的时候，我很认真我还拿到牌有的上台然后过后Form 2开始我就谢谢 因为以前我们要跑农田啊，跑农田啊那种路很难走的嘛，然后啊又很累嘛。后来不理他了，以前的因为没有，以前我那个年代啊没有像你们现在这样子动不动就有那种奖牌拿嘛，我们以前是给钱的。后来第一次听到讲有原来中学有奖牌拿了，我就很认真的跑一次啊，就为了那个奖牌的问题拿了过后，后来哦习惯了啊，就没有再拿过，就已经觉得很省了。嗯， 蛮好了，我们等一下嘛喏。那 let me know 啊。嗯，选择偏向的意思，你也可以讲。当然啊，会偏向 reduce，因为它 OK，它是这样子的。当你的那个在 cathode 的时候哦，对不对？在 cathode，我们的 cathode 你还记得当初我们在讲的时候，cathode 是 negative 嘛，在这个情况下，cathode 是 negative 嘛。那么我如果越 positive 加去减嘛，越 negative 我们就会更加的 repel，因为它反过来了嘛。反过来了嘛，所以它反过来讲，你 cathode 是 cathode is negative terminal，so the more positive it is，the easier they can attract to each other. If more negative, like for this one, sodium is higher, so they will repel. Okay, because we have to take into consideration same terminal repel, same different terminal attract. Okay, all right. Okay, yeah. So same goes to your anode as well. Remember, for electrolysis, the cathode, the cathode and anode has different polar than the what you call that, the chemical, the water cell. Water cell anode is negative, cathode is positive. But for electrolysis, cathode is negative. What you call that? The anode is positive. It's the terbalik one. Okay, this is important. Okay, so now let's continue. So you see, the iron with higher the second this is the first what you call first factor. Second factor, the concentration of iron in the electrolyte. The higher the concentration, you will be selected for discharge. Okay, when the concentration is too high, so it will tend to choose the one that I can easily grab. So that's why the higher the concentration, the higher concentration, the one will be selected to discharge. And also, you need to check with the types of electrode. When the reactive electrode like silver and copper are used, normally the anode electrode will ionize. Okay? So, now for example, like this one, okay, here, okay, this is the process, okay, and you can see these both process, which one has the higher negativity value. You see, this one is connected to positive, positive. So here is negative. So this is cathode or anode. Cathode, negative, positive, okay. So this is cathode. So cathode choose the more negativity one. So that's why they choose the OH. Okay, this one, the reference for we are positive. Sorry, this one is the balik. This one wrong already. Should be more positive. This one should be wait. More positive, yeah, more positive. This is wait. No. This is positive. This sorry. This is positive. So this one should be anode. This one is negative. This one should be cathode. Okay, so for anode, then yes, choose the one with more positive. That's why they choose the one with more positive is sorry, more negative. More negative is this one. Okay, it's smaller. So that's why they choose the what you call that, hydroxide ion. For this one, negative. So this is cathode. Cathode choose the more negative, the more positive one. Okay, so they choose this. Okay, hydrogen. Okay, because the value more positive. Okay, can all right, got this down. Yes. Huh? Yeah, of course. You have to draw because you this is how you explain. Okay, remember how we check which one is cathode or anode? The one that connected to positive terminal will be anode. The one that connected to negative terminal will be cathode. Okay,哦，你没注意到吗？Okay, that's done. Okay, all done. Done, huh? 释放. Okay, all right, so let's see the experiment. So this is to investigate the effect of standard electrode value on the selective discharge of ion on the electrode. So how does the blah blah blah, this one only lah, okay? So at anode, the more negative value are easier the species to be discharged, while cathode, the more positive value will be easier to be discharged. Okay, I don't think so. Huh? In cathode, the one with more positive, yeah, correct. Okay. Okay, so he's using what kind of material involved? Diluted sulfuric acid. Okay, copper sulfate solution, and then wooden spring. Oh, okay. So wooden spring is to check the hydrogen and oxygen. Okay, so this is how the setup is. Okay, similar from what we always see. Okay, so all this done. Okay, we just skip. Okay, now you see from anode, the gas bubble are released. Colorless gas will be ignite the glowing wooden spring. When ignites means that is oxygen. So while in cathode, gas bubble release, colorless gas will produce a pop with a glowing wooden spring. Pop sound means there is a small explosion. So that one will be hydrogen. Now, for when we go with copper 2 sulfate, so for the anode, the gas bubble are released. A colorless gas will ignite the glowing wooden spring. So still is oxygen. Okay, last year, I think for Form 4, we have been discussed on how to check hydrogen, chlorine, oxygen, and even the nitrogen, I think. Okay, you have to have that one, very important. Okay, so for cathode, they saw the brown solid. Brown solid is copper 3. Okay, so from here you can see okay, we start with this diluted sulfuric acid first. So the ion present at the electrolyte will be this one. Sulfuric acid become hydrogen ion with sulfate ion, while water become hydrogen ion and hydroxide ion. So for anode will be the one with negative anode, which is positive terminal, connected with positive terminal. So this one. Okay, while for cathode, okay, both are only hydrogen. So here. So from anode, which one they choose? They choose the hydroxide from water. Why? Because sulfate was not selected because sulfur had reached higher oxidation number. Okay, the oxidation number is higher. Okay, while for cathode, okay, of course, is hydrogen from water. So the half equation will be something like this. Water become hydrogen. Two water will create a hydrogen gas with 4 hydrogen ion with 4 and release 4 electron. While 2 water as well another 2 water will receive 2 electron to form hydrogen gas and 2 hydroxide ion. Okay. Now, when we use the carbon electrolyte with copper 2 sulfate solution, so the ion that present will be copper, sulfate, hydrogen, and hydroxide. Okay, so the negative charge ion will be on anode, positive charge ion will be on cathode. So in anode, now they are not choosing the sulfate as well. Okay, why? Because the sulfur has reached a higher oxidation number. However, in cathode, they choose copper. Why? Because the standard, what you call it? What is it? The name already. The E value is more positive. Okay, so this is their, what you call that, half equation. Okay, so I just, why I didn't go too detailed on this, Because normally they won't come out in your paper 3. Because this one need very long, what you call, long time to do. Okay, the concentration one, okay, we will just, for concentration one, we will just, okay, now, when we use the same, it's the same thing, they are actually using the same thing. Now they are using the, not diluted, this one is concentrated hydrochloric acid. So now in anode, okay, anode, now you see in anode, this one is hydrochloric acid. Okay, so hydrochloric acid, there is water and hydrochloric acid. Hydrogen chloride, sorry. So you have what? Chlorine, you have you have chloride ion, hydroxide ion on anode, hydrogen ion on cathode. So for anode, the gas bubble will be released. A greenish yellow gas with a pungent smell is released. So it will change the moist blue litmus paper, turns red, and then bleach. Bleach means become white color. Okay, because this is chlorine. Now, okay, now for this one is using the gas bubble are released. A color, this one is hydrogen, so that's why you will use the lighted wooden spoon, okay, with a pop sound. Okay, now this one is a lower concentration. This one is a diluted hydrochloric acid. So it was now you will choose oxygen. Why? Because the water has more hydroxide ion compared to the chloride ion from hydrochloric acid. 浓度的问题，这个的浓度很低吗？0.001 mol 是很低的。So OH 碱是多过 Cl 碱的，所以他就选 OH 碱，可以理解？浓度的问题吗？我浓度低是代表什么？我水多还是 hydrochloric acid 多？水多就代表 chloride and okay. Now when diluted hydrochloric acid means that hydrogen chloride higher, more concentrated, or water more concentrated. For diluted means more water, diluted, correct? More water, so chloride ion and hydroxide ion, which one have more quantity, more amount? From water is hydroxide ion, so that's why you will release oxygen because it choose hydroxide to be oxidized, to be reduced or oxidized, I think. Okay, now while for cathode they still use hydrogen. Why? Because only no matter hydrochloric acid or water, both the positive charge is hydrogen. So only hydrogen will be what to say released in your cathode. So this one no problem, 可以吗？可以理解？浓度的问题是浓度高 ，let's say 比如讲我也是冲一杯的那个叫做Milo 比较好理解OK, for concentrated it's like we are trying to make a Milo, okay, a glass of Milo. With the same glass, a more concentrated one, we will put more Milo powder, correct? So when the water is less or more, same glass, so you need lesser water, correct? Like the one, what you call that, the dinosaur Milo powder, that one, crazy one, I saw a lot of people last time. Okay, correct? Concentrated, and then you add more powder on top, so the Milo powder is more than the water. Okay, now for diluted one, so same glass again, same volume, but diluted means that low concentrated. I don't want so 高 one. So Milo more or water more? Water more. That's right, same thing. For this one, 0.01 0.001 So the HCl is Cl minus here in anode, correct? Cl minus and OH minus, which one more? OH 嘛 ，so I choose OH 哦 because it's too much to skip。OK， 因为它的选择是好像它有好几个东西影响的，它不是完全就是靠那个E 的 value。It's not only depends on E value, the E node value, because you can see from the result we have provided E node value between them are actually very small difference only. So very small difference so you will tend to choose the best one, best choice, the easier one. So like diluted one, the easier choice will be OH minus because water is more. This is how for concentrated one. Okay, 理解? Okay, now, so let's see. So the electrolysis of blah, 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 it produces oxygen gas at anode, blah, blah, blah. This one, okay, this one is the result. So the halide ion with a higher concentration in the electrolyte will be selectively discharged compared to hydroxide ion. Okay, so halide is like this one. Okay, higher concentration. Okay, so that's why for this high concentrated hydrochloric acid, it choose halide, which is the chloride. Okay, you know what's halide? But no. High concentration is halide is actually group 17. Group 17, fluoride, start with chloride, fluoride, chloride, bromide, fluoride, I think. Check your, what you call? Check your, what you call that? What's the jado again? Yeah, you check your periodic. It's okay. I will get you the periodic table. Okay, from periodic table, these are the one, group 17. Okay, these are the group 7. This one too blur. This will be your group 17. You see, fluoride, chloride, bromide, iodide, and then this one, I forget I did the name. This one, acetate. This one is acetate is name. Acetate, I think the name is. Okay. Okay, this one is the halide. Halide means that the element in group 17. Okay, so that's why group 17 with a higher concentration, they will be selectively discharged. Okay. Now for this one, very low concentrated one, diluted one, because the OH is more negative, so that's why it choose OH. If the concentration, the difference in concentration is too much, 它们之间的浓度差很远， you will choose the more concentrated one. Okay, can all right, so this one shouldn't be big issue. This one is the types of electron. Okay, this one even no issue at all. We can just skip. Okay, so let's compare the vortex cell and electrolytic cell. So for electrolytic cell, it has a battery, electrolyte, and 2 electrodes, which are connected to the battery. Like I said, the positive terminal is anode. The one that connected to positive terminal will be anode. The one that connected to negative terminal will be cathode. Okay, so you see, the electrode that connected to positive terminal is anode. Negative terminal will be connected to cathode. Now, for why it didn't show the what I call that? Why it didn't show this one? Okay, this one I think we already mentioned, so you doesn't need to copy. So in electrolytic cell, the electron are flow from anode to cathode through the external circuit. So during the electrolysis, okay, the anion, which is the negative ion, will attracted to anode, while cation, which is the positive charge ion, are attracted to cathode. So in anode, the anode anion are discharged by donate the electron to anode. So oxidation occur. In cathode, the cathode are discharged by accepting the electron from cathode. So the reduction occur. So means that the electron from anode, it will release discharge electron passing through here, go to cathode and back to the cation. Okay, you understand? Can? Sure. So this is the flow of the electrolytics in electrolytic cell. Okay, jot this down. Okay, done. Okay, so let's see redox reaction in water cell. So a simple water cell has two different metals. Okay, you see the electrode is two different metals which are immersed into the electrolyte and connected by wire. Okay, so for electrolytic, okay, the positive terminal will be cathode, negative terminal will be anode. However, for water cell, the positive terminal will be anode, negative terminal will connected to cathode. Rồi lúc tao phản mà. Hả? 我好像是弄倒反了是吗？ Let me check. I think I make it positive connected. Positive will be this one connected to positive, cathode connected to negative. Positive terbalik this one sorry ya. Ayo. This one. This one then is correct. Okay, so these are the difference between the water cell and electrolytic cell. Okay, so the more negative the electron potential value, the metal will act as a negative terminal. And at the negative terminal, the more electropositive metal will be corroded by donating the electron. That's why oxidation occur on anode. Oxidation on anode, and then what you call that reduction on cathode. This is totally different from what here. So the anion is, you see, the anode just now is what I call here is said anode is oxidation. Here the anode is oxidation, cathode is reduction. Here the anode will be donating, so oxidation for but it's on negative terminal. Yeah, it's the same. Yes, correct. So that's why last time I just changed this one. Okay, so in negative, so the more electropositive metal will be corroded. Means that we will choose the more electropositive metal. And why it will be corroded? Because the element in this has released the electron. When release the electron, it will be ionized. Ion is dissolved in water. So that's why the solid now will be corroded. However, okay, you jot down this one first. The difference, this one and these two first. Can you understand why this one is corroded? The element at first is neutral. Then it release electron, become ion. So it will be hilang and dissolve in water, dissolve in the solution. Okay? Yes. 好了，所以你冲凉的时候不会溶掉OK, bioorganic compound all are considered neutral. If no, if you are not neutral, okay, when you taking shower, the water will dissolve you. You will hilang straight away. Okay. Done, huh? Okay, huh? All right, so let's see the next one. So a positive terminal, okay, which is the cathode, cation will discharge. Okay, the cation are discharged by accepting the electron from cathode. So reduction occur. Okay, the electron from anode will move through the external circuit. Okay, the electron from anode will move through the external circuit and go to the positive charge here. The electron will go to the cation in the solution. So what happened? Here corroded, here will be thicker. Okay, so that's why the more the electron positive metal donate the electron. So the electron are flow from the negative terminal, which is anode, to positive terminal cathode through the external circuit. Okay. 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 So normally the vortex cell used for what? Used to laminate, like the one the utensil, your sudu and gapu with gold color. The one is they are actually laminated with a layer of carbide normally. Okay. Can. So normally what happens is they will use the carbide here. Here also use carbide with the carbide solution. This one, you put what? You put the gapu. And then this one, you put the carbide rod. So the carbide rod will be discharged here. Electron flow through here. So the one that discharged, the ion will be used here to laminate it a layer. OK， 这个就是电镀。OK 啊。I don't know in Malay or in what you call Tamil, but we call this what you call lamination. We call it as a 电镀 in Chinese. Okay, so jot this down. Done. All right, so let's continue with the Zhengdou. So diagram shows the voltaic cell constructed using zinc and copper electrodes. So both electrodes are connected to the voltmeter using the connecting wires, and the circuit is complete with a salt bridge. So this is the E value. Okay. I might need you to copy down this. So copy the question first. Okay, this one, the question first. Then we discuss the answer. Okay, or you can just no need copy this one. Draw this one only. Okay, draw done. Then no need to copy. Done. 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 Okay. All right. So let's continue. So based on the E value, zinc is more negative. So act as a negative terminal, while copper act as a positive terminal. Positive will act as the positive terminal. Negative will act as a negative terminal. So Zinc will undergo oxidation process by donating electron, means that it will release electron. Okay, zinc will become zinc ion and release 2 electron, and this is a oxidation process. While copper 2 ion undergo a reduction process but accept electron, means that from here the electron go through and pass here and pass to the here the copper sulfate, the copper ion from copper sulfate solution, not the one in electrode, is the one in the solution. So the copper ion from copper sulfate solution will receive electron and become copper. This is a reduction process. So zinc act as an reducing agent, copper 2 ion act as an oxidizing agent. Can you understand how we I mean explain? All right, jot down this one. This one important, you know. Okay, you wait for others done. Let me know. Okay. All right, so let's see the difference between the vortex cell and electrolytic cell. Okay, this one is vortex electrolytic cell. This one is vortex cell. Okay, maybe copy up this one so that you won't. Okay, so let's see the electrolytic cell. So the electrons are from the same or different material. So it means that both electrodes can be same or different material. The electrical energy is converted to chemical energy, and the electron flow from anode to cathode through the external circuit. Now, for vortex cell, the electrode must be from different types of metal. Okay, these two must be totally different because this one you have what I call that battery to push the electron. This one don't have. Okay, so they need the potential difference between the E value. Okay, so the chemical energy will be converted to electrical energy because this one have battery, this one don't have. So the electron flow from more electropositive metal to less electropositive metal through external circuit because more electropositive will be anode, which is the negative terminal, while less electropositive will be cathode, which is the positive terminal. Okay, huh? All right, jot this down. Done? Ini done. 嗯，electropositive 的话，electropositive 它是 positive terminal 嘛，所以在这边它应该是 vortex cell 就是刚才这一个了，就是上面这个，它应该是 cathode 来的，对吧？我没有弄错的话哦，对，因为它是 positive terminal 嘛，所以它是 cathode。我这个 vortex cell 的话，for electrolytic cell，这么它是 negative，这么 cathode 是 cathode 是接近 negative，因为 cathode 本身是 positive。OK，now for electrolytic cell it's easy for you to recognize why anode is positive. Because no, why the cathode is connected to negative. Normally, cathode is positively charged or negatively charged. Cathode normally is positively charged. So when positively charged, it will attract to which terminal? 减加嘛 plus positive to negative So that's why the cathode has to connected to negative because cathode itself is positively charged. 嗯，它不是 negative charge，它是 positive 的，所以它是给 positive charge 的 ion 啊。你看它针对的是 positive charge ion 吗？这个对，你看它针对的for cathode 来讲它的 n ion n ion 是 attract to anode 吗？positive ion 是 attracted to cathode 吗？你要这样子讲也可以啦，我只是给你一个方式去记它，这是我记的方式啊。OK，看啊。Okay, so next, so for the electrolytic cell, the reduction occur in cathode, positive cell ion will accept electron, while oxidation occur in anode, negative ion donate the electron. Now, for the vortex cell, the reduction occur at positive terminal, so the positive ion will accept electron, while oxidation occur at negative terminal by donate the electron to form ion. Okay, slightly different. Okay. Okay, all right. So I guess we'll stop here for today, Okay. So that's all for today. See you. Okay. I guess most of you need to sleep, Okay. Bye bye.
Bye bye. See you.
Oh, bye bye. Bye bye. 有开